Hello students of statics, this is Dr. Dan Baker, and today's video is going to touch on what I think is a pretty enjoyable, pretty fun, pretty challenging group project that you're going to be assigned, which is going to be due in a couple weeks time. And it's a crane design problem. And so the idea here is we're going to capitalize on some information that you've already learned in statics. Okay, you've learned how to compute shear and moment on beams, and we're going to apply that knowledge to a design example. Now, this design example is actually going to use some information that you will learn in later classes. For the civil engineers, this will be information that we presented in structural design. For the mechanical engineers, there's going to be similar kind of information that's presented in machine design. For the environmental engineers, this is just a cool thing that you get to see what happens in those classes, since you won't be taking those. But the idea is that we're going to not only figure out how much load is on a beam, but then also physically size that beam so that it can hold the load. And there's this whole PDF of all the details here, but just to kind of give you a quick overview. Fundamentally, you've been asked by a client, and this client has a boat building shop, and they've bought this crane and hoist system. Okay, so you can think that the crane has a 35-foot span, has a hoist that can move left and right along that crane beam. So they've bought that off the shelf. And what they need you to do is to design these rails. Okay, so these rails right here are going to be made out of wide flange sections, also commonly known as I-beams. They're 60 feet long. There's some limitations that the crane can't quite reach the end of the rails because of the columns, and the hoist can't quite reach the end of the crane beam because of the rails. Okay, so physical limitations, and those are all spelled out in the overall document. But what you're going to do here is you're going to think about worst case scenarios. You're actually going to use the tables that are on page 3 and 4 of the crane design problem document. And there's going to be some hints that you're going to need, right? If you're doing things that you don't know how to do yet, we're not just going to say, hey, go off on your own, good luck. But you're in a team of 4 to 5 people. Now, most teams are 4, and so if it's 4, every person gets a hint. Okay, so you can assign 1 through 4, do that however you'd like. When the birthdays are in the year, alphabetical by first name, you take your pick. Okay, so you're going to assign team members 1 through 4. Each of those team members is going to go to the page in Canvas that is the design problem page, and it has hints listed 1 through 4, and so you'll access those hints. Now, we'd prefer that you allow each person to be kind of the master of that hint until you meet as a group. Now, as you're working on the problem and you want to get a little more context later after you meet as a group and talk through those hints, you're welcome to access all 4 of those hints if you'd like. Okay, but the idea here is that this is called a jigsaw type problem, and in a jigsaw type problem, you get basically one team member that becomes an expert in each of the different areas, basically corresponding to those hints. And so you'll end up designing this beam and coming up with what you think is the appropriate size to support this crane. Now, in addition to the design problem itself, there are additionally a pre-survey and a post-survey. Okay, the pre-survey also has a video that you get to watch, and that video talks about diversity in teams. So you may guess, or you may, if you've looked at that yet, or you'll certainly see when you look at the pre-video, that the objectives of this problem are multifold. Okay, one of those is fundamentally to get to see how you'll use shear and moment in future classes, actually in a design example. Another is to get to work in teams, and another is to recognize that diversity in teams matters. Okay, so there is the pre-survey and there's also a post-survey. Please do the pre-survey before you start work with your group. Please do the post-survey after you turn in the problem. Okay, so kind of 3 phases total: pre-survey, work on the problem, and post-survey. If you have questions on this, please post them to the discussion forum or send me a quick email. I am working on this project with Dr. Becky Adadero, and so I may bring in her on some of the discussions, and she's actually the one that put together the video for hint number 3. So thank you all for your efforts in advance on this problem. Like I said, I think that you'll find it to be an intriguing design example, kind of getting to see into your future as a junior level engineer versus now at somewhere around a sophomore level. Please reach out if you have any questions.